Hello, Gen Chem students. Here is that final practice problem from your Wednesday notes. I'm going to walk through it for you, and I'll see you tomorrow morning. Metallic copper is oxidized by nitric acid because the nitrate ion is a strong oxidizer when in the presence of H3O+. Both NO as a gas and aqueous copper 2+ are formed as products of this process. So we need to locate our two half reactions. So each of these half reactions you will find in your book. So you'll need to look those up and you'll need to get their standard reduction potentials. The first one, we know that it says that copper is oxidized to copper 2+. So that is going to look like Cu solid goes to Cu2 plus aqueous plus 2 electrons. Now remember, in the table, this will look like a reduction because they're always written as reductions in your table of reduction potentials. This is the oxidation process. Therefore, this is going to be at the anode. The other half reaction, you'll look it up, you'll find NO3 minus, which is aqueous, plus 4H plus, also aqueous, plus 3 electrons will go to NO as a gas and 2 molecules of water, which is a liquid. That's our reduction, therefore it will be at the cathode. We need to balance the electrons in our two half reactions and add them together to obtain the net reaction. We have 2 electrons in our oxidation and 3 electrons in our reduction. Therefore, we need to move to an N equals 6 system where we'll have 6 electrons on each side. We'll do that by multiplying our oxidation times 3. 3 copper plus, well, that's it. We'll take this and we'll multiply the reduction by 2 plus 2 NO3 minus plus 8H plus 6 electrons will go to 3 copper 2 plus 6 electrons plus NO 2NO plus 4 H2O. We cancel out the electrons because they're on both sides, and we're going to end up with a final equation of 3 copper solid plus 2 NO3 minus aqueous plus 8H plus aqueous goes to 3 copper 2 plus aqueous plus 2 NO gas plus 4 H2O liquid. So there's our net ionic equation for this process. We figured out getting it that we have an N equals 6. We're transferring 6 electrons total. Now looking in that SRP table, we're going to find the E cell for this reduction process overall. So the E0 for the one involving copper is 0.34 volts. The E0 for the reaction featuring nitrate is 0.96 volts. We know that this one is our anode, this one is our cathode. Therefore, we're going to set up E cell, or E0 cell, equals 0.96 minus 0.34. The overall potential, therefore, is 0.62 volts. Now, using that, we're going to calculate delta G finally. So remember that delta G0 equals negative NF E0 cell. We already know N, this is 6. E cell is that 0.62 volts that we calculated, and F is Faraday's constant. It's always the same value. Delta G prime equals negative 6 times 9.65 times 10 to the 4th times 0.62. Crunch those numbers down, you'll eventually get negative 359 kilojoules. This is a spontaneous reaction. And if you want to check out this reaction in progress, I've linked to a Royal Society of Chemistry video in the description of this particular video. Enjoy, it's a really cool reaction. See you guys on Friday.